Hi, ladies and gentlemen. Note 6.4 are on transformations of sinusoidal functions. So a reminder for the general equation of a transformed function, it's always going to be y equals a times f of k times x minus d plus c. Okay, and remember f is your rule. And it's really important that you guys still continue to understand transformed functions, and if not, go back and watch some of the previous videos on it so that you can be fully sure that you understand how to do transformations on any type of function, okay? And it's going to be the same idea again, but this time we're looking at sinusoidal functions. So if f of x equals sine of x, then a transformed equation is going to be y equals a, and then f is your rule, and our rule is sine, so it's going to be sine of k times x minus d plus c. Okay, notice how the k right here is factored out. It's important that you remember to do that. Okay, so just a quick review that a is a vertical stretch if the absolute value of a is greater than 1, or a compression if the absolute value of a is between, and sorry, you're going to have to squeeze this in here, is between 0 and 1, okay? And it also indicates a reflection in the x-axis, because remember your y's are changing signs, so if you're reflecting in the x-axis, your y values are changing if a is less than 1, or less than 0, excuse me, or in other words, if a is negative, okay? Now, with regards to sinusoidal functions, the irregular amplitude of a sine function is just 1. So here, whatever you're stretching it by vertically is going to change the amplitude. So A always tells us the amplitude of our sinusoidal function. Okay, so it's always the amplitude in a sinusoidal function. All right, awesome. We also have the K value, which is the horizontal stretch. Okay, and that is going to be related, it's going to be a stretch, excuse me, if 1 over k, the absolute value of 1 over k is greater than 1, because remember you have to do a reciprocal, okay? And it's a compression if the absolute value of 1 over k is between 0 and 1. Okay, and it's a reflection in the y-axis if k is negative, or if k is less than 0. Okay, k must be factored out. Some of you guys are still forgetting to do that. It's really important that you factor that k out, okay? And then, because otherwise the d value is going to be incorrect, okay? And k also helps us to find the period, and we'll talk about that shortly. But remember, the period tells you how long it takes to complete a full cycle. So if you're stretching it or compressing it horizontally, your cycle will end up being either smaller, it'll take less time, or it'll be longer, it'll take more time to complete a cycle. That's if you stretch it or if you compress it. Okay, all right, next, D is still going to be our horizontal shift. And remember, it's always the opposite sign, okay? But this time, the horizontal shift is going to help us find the phase shift. And we'll talk about that a little bit more in a few minutes. And then C is going to be the vertical translation or shift, okay? And let's put in brackets that another word for this is a translation. And then here, this is still going to be a horizontal shift or translation. Okay. And then C is also called the something. We'll talk about what that is right now. So remember, if we have a sine function right here, okay, if our axis is in a different spot, simply all we've done is shifted it vertically. So C is also called the equation of the, or sorry, it's just the axis, okay? And then the equation will always be y equals c. Okay? All right, so we're going to transform the graphs of sinusoidal functions in a slightly different way than we've been doing before, but the original method still applies. So when we get to sinusoidal functions, you actually have a choice between either method. So the first thing I want you to do is to find the equation of the axis and use a dotted line to represent it on your graph. Because once I know what the equation of my axis is, I know where everything is centered around. So let's say, for example, I were to find the equation of my axis, and it would be right here. Okay, so this would be the equation of my axis. Sorry. This would be the equation of my axis right here. Okay, then it says draw this should say two more dotted lines to indicate the minimum and the maximum. Okay, so I'm going to go ahead and do that to show you what it's going to look like. So let's say, for example, this right here is my max, and this right here is my minimum. Okay, the next thing I'm going to do is I'm going to identify the period. And to find the period, I take 360 degrees because that's a full period, and I divide it by k because k right here, 1 over k is my scale factor. So technically, I'm multiplying it by 1 over k. We do the absolute value of it because our period is always positive. And then essentially what you're doing is you're just taking 360 and dividing it by k to find your period, okay? And then using the period, you're going to label the 5 key points, okay? So let's say, for example, right here, we have our period. It ended up being this is one full period and then this is another full period. And I'm purposely using ambiguous numbers so that way you can get a general idea of what it's going to look like. So before we do that, we need to go back and identify what the key points are for our sine graph and what the key points are for our cosine graph. So for our sine graph, the key points that we have are going to be where the axis is originally. And remember, sine will always start on the axis. Cosine starts at the maximum, okay? So sine will start on the axis, and then we have it will reach the axis again at 180, and then it will reach the axis again at 360. So those are 3 critical points. But we also have the maximum, which will happen at 90 degrees, and the minimum, which will happen at 270 degrees. So the key points on the sine graph will end up being 0, 0, okay, 91, 90 degrees, comma 1, okay. The next one will be 180 degrees, comma 0. The next one would be 270 degrees, comma negative 1. And then the last one will be at 360 degrees, 0. Okay? Now, for the cosine graph right here, remember the cosine graph starts at the maximum right here, and then it reaches the axis at 90 degrees, and then it reaches its minimum at 180 degrees. It reaches the axis again at 270 degrees, and then it reaches its maximum again at 360. So that's how it completes that full cycle. So the key points on our cosine graph will end up being 0, 1, 0 degrees, 1, and then here we have 90 degrees, 0. Here we have 180 degrees, negative 1. Here we have 270 degrees, 0. And lastly, we have 360 degrees, 1. Okay, so those are the key points on the cosine graph. All right, awesome. So once we draw our key points, we have to be careful of any vertical reflections because then we're going to have flips that we need to be careful of, and that happens when A is negative, okay? And then you're going to draw your function, and this is the function without the phase shift. It's really important you understand that the phase shift has not happened yet, okay? So let's say, for example, we have a sinusoidal function. So that means it's going to start on the axis, okay? And it needs to complete a full period by this pink mark that's marked off on the x-axis. So right here it needs to complete a full cycle, and it's going to meet the x-axis or the axis halfway in between, okay? It's also going to reach its maximum somewhere around here, and then it's going to reach its minimum somewhere around here. That's if there's no reflection, so it would end up looking like this. Again, it's more complicated than this. I'm just giving you a general overview of what's going to happen. Then you're going to apply the phase shift. So here we want to apply the phase shift, which is essentially just your horizontal translation. So what I would do is, if I need to shift this over, then let's say it's supposed to be, for example, over here, I would just shift it over, and then it would end up looking like that, okay? And then you would draw the new function, and then you're good to go. Again, it's a little more complicated than this. It's just an overview. So now let's go ahead and actually apply what we learned. So example number 1 says to draw 2 full cycles of f of x equals 2 times sine of 3 times x minus 20 plus 1. And remember, the k value has to be factored out. So the k value right here is factored out. So right here, the equation with the k value factored out is still going to be f of x equals 2 times the sine of 3 times x minus 20 plus 1. Okay, and here we're going to just identify all of our values. So here we know A is 2. We know that K is 3, which means that the scale factor is 1/3. Okay, we know that D is going to be positive 20. Okay, and we know that C is 1. And remember, the equation of the axis is always going to be y equals c, okay? So the equation of our axis here is y equals 1, okay? The amplitude is always a, so my amplitude is 2, okay? Now the period in a normal cycle is 360 degrees, okay? But our scale factor here is 1/3. So you know how we said to find the period, we would take 360 degrees and divide it by the absolute value of k, and k is 3. So it'd be 360 degrees divided by 3, so it'd be 120 degrees. So my period is 120 degrees, and that should make sense to you, because if the normal period is 360 degrees and you're compressing it with a scale factor of 1/3, that means that it would take 1/3 of a period to complete a full cycle. Okay, or 120 degrees. Now, if our axis is 1, then our minimum is going to, and our amplitude is 2, then our minimum is going to be 2 above 1. So our maximum is going to be 2 above 1. So we're going to say that our max is 3. And then our minimum value is going to be 2 below 1. So our minimum will be -1. Okay, and then remember, your phase shift is always going to be whatever D is. So here it's going to be 20 degrees because it's positive. It's going to go to the right. Okay, now remember, sine, the critical points are going to be 0 degrees has a sine of 0, 90 degrees has a sine of 1, 180 degrees has a sine of 0, 270 degrees has a sine of -1, and 360 degrees has a sine of 0. Okay, so now my axis is at 1, and my min is -1, and my max is 3. So I'm going to draw my x-axis a little bit lower down, because I want because there's more values that are higher than 0 than there are less than 0. So I'm just going to go ahead and draw my x-axis right here. Okay, and then my y-axis I'm just going to draw right in the middle, because even though we need to have 2 full cycles, I want to show it in both the positives and the negatives. Okay, so if you guys notice right here, we need to label this right here x, and we're going to label this right here y. Okay, and we need to complete a full cycle in 120 degrees. Okay, so right here, what I'm going to do is I'm going to put 0 here, and I'm going to space it out so that I have 120 degrees over here. So I think that if I go if I put 30 degrees here, and then I can put 60 degrees here, 90 degrees here, and then I'll put 120 degrees here, and then I'll do the same thing back here. So -30, -60, -90, and then -120. Okay, so now what we're going to do is draw in our axis, the line for the axis, the equation of the axis. So again, we want this line to be dotted so we don't get it confused with the rest of our graph. But first we need to actually label our y-axis. So I think if we if we go by halves, I think that would be a good place for us to put everything, so that way we can kind of see everything a little bit better. So I'm going to draw in my equation of my axis right here. Okay, and I'm going to put in my minimum and my maximum. So let me just color code this so it's the same colors as what we have right up here. So our minimum was -1 right here, and our maximum was +3 right here. Okay, so that means that our graph is going to oscillate from the center here up and down and up and down, okay? And we need to complete a full cycle by 120 degrees right here, okay? Now, we know sine always starts in the middle, okay, right on our axis. So right here, if sine starts on our axis, then we will have our first starting point right here, okay? And the cycle will go up and then back down, and then back to the center. So at 120 degrees, it should complete a full cycle, okay? But we also know that a sine curve always completes a full cycle, but halfway through, it reaches the axis again. So half of 120 will be 60. Okay, and then halfway between the initial point and the midpoint, right here, we'll reach our maximum. So right here, halfway between 0 and 60 is 30, or a quarter of the way between 0 and 120 will be 30 right here. So I'll put a dot up here. Okay, that's where my maximum is going to be. And then 3/4 of the way through the full cycle, or halfway between the second half, or at 90 degrees, we'll reach our minimum. Okay, and I didn't have to do any reflections at all because the amplitude, sorry, the A value here is positive. Okay, so that's one full cycle right here. But we want to complete 2 full cycles. So what I'm going to do is the exact same thing on the left side. You could do it on the right side. It doesn't matter because it didn't specify here where you need to do it. Okay, so again, I'll complete a full cycle by between -120 and 0. The halfway point is at 60 degrees, okay? The maximum will occur at -90 degrees, and the minimum will occur at -30 degrees, and now I have my 2 full cycles right here, okay? That's what happens without the phase shift. Now, with the phase shift right here, we know that it's going to go 20 degrees to the right. So in order for me to be able to do that, I literally will just take each one of my points right here and just go 20 degrees to the right. So 20 degrees to the right of -120 is -100. So that will occur approximately right here. Okay, 20 degrees to the right of -90 will be at -80, which is approximately right here. Okay, 20 degrees to the right of -60 would be -40. Which is approximately right here. 20 degrees to the right of -30 would be -10, which is approximately here. So on and so forth. 0 plus 20 would give me 20. 30 degrees plus 20 will give me 50 degrees. 60 degrees plus 20 will give me 80 degrees. 90 degrees plus 20 will give me 110 degrees. And then 120 degrees plus 20 will give me 140 degrees. So now I'm going to go ahead and connect these dots right here. And the pink graph right here is going to be f of x. Okay, and because it asked us to do 2 full cycles, no arrow, sorry, I shouldn't have put the arrow there. If it didn't ask us to do 2 full cycles and it just asked us to graph it out, we would put arrows on both sides. All right, example number 2, draw 2 full cycles of g of x equals -3.5 cosine of 0.5x plus 22.5 minus 2. So the first thing we need to do is make sure that the k is factored out. And if you see right here, there's no brackets here, which means the k is not factored out. So we have to factor that out. So that means that my equation is going to say g of x equals -3.5 times the cosine of 0.5, and then when I factor out the 0.5 from the 22.5, I have to divide it out. So I end up getting 45. So I'm going to say x plus 45 minus 2. Okay, Do not start anything at all until you've gotten it in the form where the k is factored out. So here we can say that a is negative 3.5. Okay, we can say that k here is equal to 0.5. We can say that d is negative 45 and that c is negative 2. So the equation of my axis is going to be y equals negative 2. Okay, the amplitude here is going to be 3.5. Okay, but don't forget that there is also a vertical reflection. Now this is going to be a little bit different when we actually graph this out here, okay, the way we do it. To find the period, remember we have to take 360 degrees and divide it by the absolute value of k. So I'm going to take 360 degrees and divide it by 0.5, which would end up giving me 720 degrees. Again, that should make sense to you because if k is 0.5, then our scale factor is the reciprocal of 0.5. And remember, 0.5 is 1/2, so the reciprocal of 1/2 is going to give me 2. Which means that it's going to be stretched with a scale factor of 2. Therefore, my period should be twice as much as 360. Okay? Now, to find my minimum or my maximum, it comes from the equation of the axis and the amplitude, because this is your center point. So the amplitude of 3.5 means it's going to go 3.5 below negative 2 and 3.5 above negative 2. So that means that my minimum is going to be equal to negative 2 minus 3.5, which is negative 5.5, okay? And my maximum, so we'll write down that we did negative 2 minus 3.5, and then our maximum is going to be negative 2 plus 3.5, which would bring us to 1.5, okay? And then lastly, our phase shift, remember, comes from the D, and it says it's negative 45, so that means that this goes 445 degrees to the left. Okay, so now I want to set up my axes, and in order to be able to do that, I need to take a look at where everything seems to end up being. So first of all, I'm going to still put my my y-axis in the middle because I want to have 2 cycles again, and I want to show the cycles in both positive and negative. In the future, if you choose to do all positive or all negative cycles, as long as it doesn't specify how they want you to do the cycles, it's totally fine. Now, because our minimum is negative 5.5 and our max is 1.5, we have more negative values, so I'm going to draw my x-axis a little bit higher, okay? And so I'm going to label right here, this is my x-axis, and this is my y-axis. Now, since my period is 720 degrees, I want to make sure I get all the way out to 720 degrees. So I think what I'll do is I will put each block will be 45 degrees. So if this is 45, then this is 90. This would be 180. Okay, we've got 270 here. We've got 360 right here. And then we have, and I'll just put little tick marks so that it's a little bit easier to see where we're at. So right here we've got 450. Here we've got 540. Here we've got 630. And then we'll squeeze in our 720 over here. Technically we want to make it fit, but that's okay for now. So then I'll put negative 90 here, negative 180 here, and I'll just keep going. All right, awesome. Next thing that I want to do is draw my dotted line for my equation of my axis. So the equation of my axis is y equals negative 2. And again, I forgot to label my y-axis, so let's do that first. So I think if we use half blocks again, I think we should be okay. Let's just make sure 1, 2, 3, 4, 5, 6, 7, 8. No, we will not be okay, so we'll use each block, it will be, each unit will be 1. So this will be negative 2, this will be negative 4, okay, negative 6, negative 8. Okay, so now I want to draw in the equation of my axis, which is at y equals -2. So I'm going to draw a dotted line right at y equals -2. And then I'm going to draw in where my minimum line is going to be and where my max line is going to be. So my minimum line is going to be at -5.5. So I'm going to go halfway between -5 and 6, and I'll adjust that in a minute. And then the max is going to be at 1.5, so I'll go halfway between 1 and 2. Again, I'll adjust that right now. So here's 1.5. Okay, and then this right here would be -5.5. All right, awesome. Now that I've done that, I want to think about what my parent function is going to look like. So it's cosine. And remember, for cosine, cosine of 0 degrees is 1, cosine of 90 degrees is 0, cosine of 180 degrees is -1, cosine of 270 is 0, and then cosine of 360 is going to be 1. So our parent function, remember, whenever we have, if this is where our axis is going to be, it always starts at the maximum, goes down, and then back up. So this is always our parent function for our cosine. So here, what's happening is we need to finish our period within 720 degrees. So we finish our cycle within 720. So from here to here, we need to complete a full cycle. And we would normally start at our maximum. So here we would normally start right here. However, our graph has a vertical reflection. So this time it's going to start at our minimum, go up to our max, and then end at our minimum. So right here, instead of starting at our max, we want to start at our minimum, which is -5.5, which means that our full cycle will complete at -5.5. Okay, it also means that it will reach our maximum. Normally it would reach our minimum at the halfway point. Now it's going to reach the maximum at the halfway point right here. So we'll put our dot right there. Okay, and then halfway in between, so for the first quarter right here, it always reaches the axis right halfway in between. So this is going to reach our axis halfway between 0 and 360, or a quarter of the full cycle. So it's going to reach our axis at 180 degrees right here. Okay, it's going to reach its maximum, and then it's going to go back down, and it's going to reach the axis again halfway between the second half of our cycle, or 3/4 of the way through. So this right here is going to be one full cycle. Okay, now we're going to work backwards and do the same thing on the other side. So again, it's going to start at -720 at the minimum this time, because it's a reflection. It's going to reach the maximum halfway through. It's going to reach the axis a quarter of the way through, and 3/4 of the way through. So this is what it's going to end up looking like. Okay, but this is what it looks like without the phase change. So now we also have to take it 45 degrees to the left. Okay, so each block right here represents 45 degrees, so that's convenient. So we're going to go ahead and go 45 degrees to the left. So we'll go one block to the left here. We'll go one block to the left here. And we're just going to keep going, because this right here is our phase change. And then this is the way our graph will end up looking. Okay? And those are our two cycles. Okay? And let me just adjust this piece right here, because it should not cross over like that. Okay? And that's it. So let me know if you guys have any questions, and I will see you guys in class. Bye.